recording, and we are live. All right, so welcome back. So any questions from what we've done so far? We did kind of a crash course intro to classes yesterday, made a rectangle class. So any questions or comments from where we are right now? And when I ask questions like that, I can't see people raising hands, so I'll usually just wait a few seconds, and if I don't hear anything, I'll just go on. So if you do have a question, jump right in, particularly when I ask, are there any questions? Otherwise, I'll just keep talking for the next 50 minutes. All right, so let's talk about programming assignment 1. So PA0 got turned in. That looked good for everybody. There were a couple of people who did not turn it in, and I've written them emails. So if you got an email, if you check Canvas for an email from me, that'll tell you if you succeeded in turning in PA0. If you got an email saying there was an issue, please write me back today and let's figure it out, okay? Because you're going to use this submission method the rest of the quarter. Yes, question? Someone raised their hand. Or perhaps not. Okay, I'm going to assume my audio is not broken, but if you raised your hand and you're not, I'm not responding to you, raise your hand again. All right. So PA0 looks good, okay? PA1 is more complex than PA0. It's more than a hello world. But it's still fairly straightforward to do once you're comfortable with the idea of objects and classes and what an object is. There's not a lot of intense computational aspects to it, but it can take a while to sort of get your brain thinking in the terms it needs to for PA1. So let's go ahead and take a look at that. And I just updated this a few minutes ago because I had some things I omitted earlier. So if you downloaded this, please download it again because it's got more detail now. So programming assignment 1. You're going to create a class for working with even numbers, basically. It's going to be kind of a new type of integer class that looks just like integers except that it only handles numbers that are divisible by 2. Okay? You're going to add, subtract, multiply, divide. We already have ways to do that in Java, so you don't have to do a whole lot of work as far as coding. The real challenge here is sort of coming to terms with the mechanics of object-oriented programming. So you can't start this the day before it's due. It's going to take at least a few days, if you're totally new to this, for your brain to kind of wrap itself around the ideas of objects and encapsulation and information hiding and those kinds of things. The purpose of this assignment is to get your brain going in those directions so that as we move into more complex programming assignments, you've got a solid framework to stand on and build from. So give yourself some time. Let yourself struggle with this, okay? Most people, anytime you learn something new, there's a struggle that takes place. And that's essential here, okay? You don't really want it to be easy because you want to learn something new here, right? And the struggle tells you that your brain is rewiring itself for these new concepts. So start early. The other thing, I do not want you to use any integrated development environments. Don't use Eclipse, IntelliJ, anything like that. I want you to work from the command line on the Linux server, or if you have your own Linux environment, the command line from there, okay? Compile with Java-C, execute with Java, edit with VI, Notepad, gedit, whatever your favorite editor is. Preferably VI because it'll help you in life, but stay away from IDEs, okay? The reason being, I want you to type in by hand public static void main parentheses string bracket bracket args close paren curly bracket. I want you to type that like millions of times over the next few weeks, so that when you get to an exam or you get to a situation where you're coding for a job interview or something like that, this is second nature to you. Okay, and you don't need to rely on your notes or on an IDE that fills in, the prototype for a main method and so on and so forth. Spend the time to actually type this stuff in to a command line. Okay, it'll definitely pay off down the road, including when you're at a university. Okay, so you're making one class. It's called even. So it's going to sit in a file called even.java, and it's a class that corresponds to even whole numbers, okay, integers. You can add, subtract, multiply, and divide. You can also convert an even into a plain old integer using a method you're going to write called toInt. Okay. Even numbers, if you add, subtract, and multiply them, you always get even numbers. So we have what's called closure. Division is a little different. Now, when you divide integers, you get truncation. So if you do 10 divided by 8, that would normally be 1 point something. That'll get truncated to a 1. Okay. 10 divided by 5 would just be 2. 10 divided by 4 would be 2.5. That would get truncated to 2. But division, you can sometimes end up with an odd number. So if you end up with an odd number when you divide, add 1 to it to make it even. Okay, that's the required rule. So if any time you end up with what's supposed to be an even number and it's odd, add 1. If it's -7, make it -6. If it's 1, make it 2, and so on. Okay, we have a single constructor for evens. It takes a single argument, which is an integer, and it basically assigns that integer to whatever you're using internally inside your class to store your number. So so what does this look like? You're going to make a class. So class even. Make it public. And this is very much like what we did with the rectangle. In fact, you can use the rectangle code. All the code is posted on the Linux server. You can get to it through Canvas. You can use the rectangle class as a template, right? And I'd rather you didn't copy and paste too much, but you can look at it to help you understand and remember how we write classes. We said public class rect yesterday. For you, you're going to say public class even. Okay. This says I'm defining a class. This is the name of it. This is a keyword. This says it's accessible to things outside of this file. And you're going to have some methods in here for adding, subtracting, and you're going to have a toInt and a toString that we'll talk about and so on. And you're going to have a constructor. So your constructor is going to be something like public even. And it's going to take an argument, which is an integer. So I'll just call it integer arg. Okay, so how are we going to capture the essence of an even number in this class? We're going to need a variable, what we'll call a class variable, that holds the value of our even number. So for example, I might just say, outside of any of my methods, integer value. And maybe I'll initialize it to 0. Just for kicks. Okay, and my idea is this is the integer that represents the value of my even number. So in my constructor, if I want to make an even number equal to arg, I just have to say value equals arg. Okay, and when I want to know what the value of my even number is inside a method, it's whatever value is. Okay, this is kind of like a global variable within this whole class definition. Okay, so these kinds of globals are legal and good. It's technically called a class variable. Okay, it's a piece of the class. It's like a field in a structure statement. Okay, so constructor, again, nothing stops the person from calling this constructor with an odd number. If they try to construct an even with an argument of 3, we don't want to set the value of this to 3 because it's always supposed to be an even number. Add 1. Okay, if they try to construct an even 3, make it a 4. So you need some code in here, right? Check your argument, and if it's not even, then add 1 to it, right? And store that in the value. How do you tell if something is even? If this thing modulo 2 is equal to 0, then it's even. Okay. If this thing modulo 2 is not equal to 0, then it's odd. And stick with those. Don't check to see if it's equal to 1, because if it's a negative number, this could end up being negative, right? But if positive, negative, if it's divisible by 2, arg mod 2 will be 0. And if it's not divisible by 2, arg mod 2 will be non-zero. Okay, so that's a helpful hint. All right, we have 4 main methods for manipulating an even: add, subtract, multiply, and divide. And the way these work, if x is an even and if y is an even, we can say x dot add parentheses y. Okay, what does this mean? It means x has a value associated with it. Take that value, add the value associated with y, and return a new even. Okay, subtract, return a new even corresponding to x's value minus y's value. Multiply is just multiplication. Div is division. But if the result of that division is odd, add 1 to it to make it even. Okay, so we have these 4 methods. So let's look at what one of these might entail. Let's look at the add method. So the add method is supposed to return an object of type even, and it takes an argument. I don't know, I'll just call it y. Okay, well, first thing we need to do is find the value of y. Okay, so value of y equals, well, if we're defining a class where we have a field called value, right? This could just be y dot value. So I'll make this an integer. Value of y equals y dot value. Integer sum equals value plus value of y. So that's the value of whatever object I'm calling add from, right? Added with the value of y, and I'm storing that in sum. And then I make a new even result equals new even, constructed using this sum, and then I could return result. Okay, this is a bit of a long-winded but hopefully pretty clear way to implement this function, right? We get the value of y, we add it to the value of this object. That gives us an integer, which is the sum. We construct a new even using that called result, and then we return result. Very step-by-step straightforward, right? And there's some things to think about in here. For example, what happens if the sum is odd? Well, we could do a check and we could say, you know, if sum's not divisible by 2, let's go ahead and increment it. But if you've written your constructor correctly, you can pass an odd number to this and it will do the right thing. It will add 1 to it and construct an even based on that incremented value. Alright, we're also going to have to do something about this, which we'll talk about in a moment. But let me point out, you could write this in a single line of code. Okay, you could return parentheses new even parentheses value plus y dot value. Put that all in one line. But you know, spell it out like this if you want, especially when you're first writing these methods and first figuring out how these pieces go together. But keep in mind, you know, you can also combine stuff in steps, and it's useful to be able to do that sometimes. All right, let's go back to PA1. So there's a fifth method called toInteger, toInt, and that should return the value of an even number as just a plain old int. So it takes no argument, it returns an int. And for example, if I were to say something like even x equals new even 6, and I said integer I equals x dot to int, that should set I equal to 6. And if I said integer x equals new even parentheses 5, and I said integer I equals x dot to int, that should still set I to 6, because when I construct an even with a 5, the value of that even number is actually 6. It gets incremented according to our rules. And so toInt tells me basically the value of this object x, which should be a 6. Okay, why do we have a toInt? Because when we define our even class, we want to make this private. Why do we want to make it private? Because if this is not private, somebody can do the following. Even x equals new even. And then they could say x dot value equals 5. And now x is supposed to be an even object, but its value is odd. And that could potentially damage our code. I mean, it could cause our code to do unexpected things. If we're working under the assumption that the value of this even number is always even, right? Somebody has just circumvented that by setting the value explicitly. By making value a private element of this class, this will give me a compile error. Okay, the compiler will not let me run code that explicitly assigns a value to this. Which means that the only way we can change the value of an even number is either to construct it or to add, subtract, multiply, or divide, which is exactly what we want. But having done that, having made value private, this code is going to break, because it's going to say value is a private member of x. So what we really need to do is call the toInteger method. So we could say value of y equals y dot toInt. And toInt, which is part of the even class, has access to that private value, and it can return it as the value of the method. All right, I'm going to pause my screen share for a second. Alright, sorry about that. That was weird. I tried hopping out for a minute and it would not let me back in. I had to like kill my whole Zoom thing. Anyway, okay, so we have our toInt method, which basically takes the value of an even and returns it as a plain old integer. So that's the accessor that we were talking about yesterday when we were writing a get height and get width pair of functions for our rectangles. And I'll come back to toString in a moment, but you should be able to do things like this. A equals new even -10, B equals new even 15, C equals A add B, D equals B divide A. Okay, these should let you manipulate even numbers. Okay, so when I try to do something like concatenate an even number to a string, what should happen? Now we saw yesterday if we just do this as is, we'll probably get something that looks like even @ and then a 6 or 8 digit hex number. So you're going to write a toString method. And toString is going to return a reasonable looking string that corresponds to your even number. And it returns the string as a series of words separated by spaces. So if your number is 16, it should return the string 1 space 6, okay, ONE space SIX. So for example, in my test code, I said A equal to -10. When I said print line A equals, and I concatenated A, the output I should get is A equals -10. That's the number 10. When I said B equals and concatenate B, the toString method of B should return the string 1 space 6, okay, meaning the number 16. So toString is returning an English version of your number, expressed as a series of words, 1 word per digit, okay, where the word is, you know, either 0 through 9, or if there's a minus sign in the beginning, print out return the word negative. Okay, so it kind of looks like, it's telling you in words what your number is. So how do you do that? Some suggestions in here, right? Consider turning your integer value, the value of the even number, into a string. You can do that by concatenating it to an empty string. So for example, go back to our class. So you're inside your definition of the class even, and let's again say value is the value of our number. I could say something like string temp equals empty string plus value. Okay, now temp is a string corresponding to the value of this. If value is 16, temp would be equal to a 2-character string 16. And once we have a string containing the digits of our number, we can loop based on, an index variable from 0 up to the length of this string, right? So 0 and 1. And there's a character at method associated with strings that will return the character at a particular position. So if I say this string.char at 0, I'll get the character 1. If I say this string.char at 1, I'll get the character 6. And once you have the next character of your string, you can write a bunch of if statements or a switch statement or whatever you like to take the appropriate string and append it to a running string with spaces in between. Okay, so this takes some thought, but play around with it, right? You can write this at the end, right? It doesn't really affect any of your other methods. But once you've got the other stuff working and you're confident you're constructing evens and manipulating them correctly, you can go ahead and you can start playing with the toString method and see what it returns. And important note, right? toString does not print anything. Okay? Usually we use it in a print statement, but if I just call toString, I should not end up seeing any output produced. toString simply returns a string. Okay? And that's really important to keep in mind. So toString simply converts the value of your even number into a string, and it returns that string as the function value. Okay, it doesn't actually print. Okay, so there's sample code that I put in the assignment that will exercise your even class. And up here we just make a few numbers and we manipulate them, we add and we divide them. Here we take a even number C, initialize it to 2, and then we keep multiplying it by even number D, which is also 2. This should give us powers of 2, right? Each time we do this, C should be the next power of 2. And then I print it out like this, and here's the output I get. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 11th is 2048, that's 2048. Okay, so this is just, playing around with it. You want to do your own tests on your even class. This is not exhaustive, okay? I'm not testing the toInt function. I'm not actually testing multiply and subtract. So make sure you do lots of tests, okay? But generally, if your code works for a few cases, it's probably going to work, okay, for this particular code. There's not a whole lot of edge cases, but play around with it. Give yourself a lot of tests. If you want to swap test programs with other students, that's fine. If you want to give somebody your main program and get their main program and use that to exercise your even class, that's fine. Just don't share the code for even.java. Alright, so you submit on GitLab just like PA0, put it in a repository called CSE223 PA1. Okay, make sure I'm a reporter. And then grading is based as follows, so I'm giving you a precise rubric for this assignment. If the class is defined properly, meaning you say public class even curly bracket, if I can compile your class, and if the result is an even.class file, and you've got a constructor, you got 25 points out of 100. Okay. If you write the methods for add, subtract, multiply, divide, and toInt, right, and they have to compile, because if it doesn't compile, you don't get any points. But if you write these 5 methods and they compile, you get another 25 points. So there's 50 points out of 100. Additionally, if add, subtract, multiply, divide, and toInt all work perfectly, you get another 15. Okay? They all have to work, though. If there's a problem with divide, you don't get your 15 points. So make sure that you test these. Okay? Chances are, if you can write one, the others look almost exactly the same. Alright, toString gets you another 15 points, so now you're up to 80. So toString is kind of its own challenge. Okay, but leave it for the end, I would suggest, and spend some time playing with it. Alright, so that's 80 points. The last 20 points is style, and style is going to be a major consideration in this course. Okay, I want to see clean coding. I want to see lots of documentation in your code. So here's what I mean by 20 points worth of style. Consistent indenting, consistent placement of braces, and so on. I'm still going to let you decide how you want to do this, but I want you to do something that's consistent. Anytime that you start the body of an if statement, the body of a loop, the body of a method, the body of a class, those should be indented. Okay? If you're inside a while loop, those statements should be indented. If one of those statements is an if, the body of that if statement should be indented further. Okay? It's up to you if you indent with spaces, tabs, 2 spaces, 3 spaces, 7 spaces. Totally up to you. But be consistent. Okay? So that just eyeballing your code, the reader can tell what part of your code does this line belong to, just by the nesting level. Okay, same thing with placing braces. Do you place them on the same line as an if, or do you place them on the following line? Are your braces indented or not? Be consistent. Okay? Play around with it. It's a chance to express your individuality, right? Coming up with your own coding style. Do something that feels good. All right, comments. Pretty much every line of code should be commented. Okay? And make your comments reasonable. If you have a line that says I++, semicolon, don't say increment I. Okay? It's a comment, but it's not really an informative comment. Why are you incrementing I right here? Right? What does this represent? What are you doing? What information are you updating, and why? Because of this statement. Okay? Add one more to the total number of inputs. Right? Count the number of times we've gone through this loop. Keep track of the number of elements so we can compute an average later, right? But explain to the reader why you have each statement of code. Okay? So I'm going to be really, really kind of dogmatic about this. So I want lots of comments. I also want, before each method, a block of comments that completely discuss what this method is. Okay? So for example, if you're writing your divide method, here's an insufficient comment block, something that says div method. Okay? Technically it's a block of comments, that's not what I'm looking for. Here's an excellent example of a comment block. Div method, accept an even integer and divide the current object's value by the argument's value. Okay? That tells the person looking at your code exactly what this method does. You can go further, right? If the result is odd, add 1. Well, that's really good to know if you're going to use this method and you've never seen it before and you don't have the documentation for PA1. How do you know this? Well, maybe you look at the code for div and maybe you figure out what this %2 business is doing, but explain it in the top of the function, okay, in that comment block right before the method. Return a newly constructed even object with the resulting value, right? We're not modifying the argument, we're not modifying this object's value, we're creating a new even object with the resulting value. Here's another note that's worth having: no special handling for division by 0. Right? If somebody uses your divide method to divide by 0, the Java compiler will throw an exception, an error. That's perfectly okay. But it's worth telling the person looking at your code that that's what's going to happen. Okay? And then I similarly want a block in the very beginning of the class that describes what the class is. Okay, so don't just say this is the even class. Say, you know, this is a class that represents even numbers. It works like integers, but the values are always even. You can add, subtract, multiply, and divide using corresponding methods. If the result of an operation is odd, we add 1, etc., etc. Right? So I want lots of good, clear documentation in here. Again, this is going to help you so much down the road. When you get to a university, you're going to have to be doing really good documenting. And most of the time, people start losing a lot of points in their first few assignments, possibly their first few classes at a university, because the bar gets a lot higher really quickly. So come into university, right, with really good coding habits, really good style, and a habit of documenting. Okay, now for PA1, it's due in a week. It's due Tuesday at 8 a.m. If you want to send me your code before the weekend, all right, push it over to Git. Shoot me an email and just say, hey, my code's on Git. Can you look at it, tell me what you think of the style, or tell me about the commenting or something like that. I'll be very happy to give you feedback and say, you need more commenting here, or your style is missing this kind of thing, or stuff like that, right? So you don't have to be surprised when you get your grade back. You can show me your stuff ahead of time. I'm just going to ask that you do it before the weekend is over, okay, so that I don't get slammed Monday with a bunch of requests. A submission again is on GitLab, CSE 223 PA1, all uppercase. Make me a reporter. I would like the repository to contain just even.java. If you want to put a README in there, you can put a README in, okay? But don't put in even.class, don't put in your own main test programs, and so on and so forth. Just put the even.java file and an optional README if you like. So you may want, I'll let you figure out how you want to do that. There's lots of ways. All right, that's basically the lowdown on PA1. So any questions about that? Yes.
You were saying that the add method will return an even.
Correct.
Can you talk a little bit more about that?
Sure. So like back here was an example of an add method, right? So it takes an argument which is an even, find the value of that argument, add it to the value of this even, right? Make a new even by using the new keyword, so call the constructor, make a new even with the required sum. I'm calling that an even named result, just return it. And when you define your add method, right, which is public, instead of saying it returns an int or a float or something, I'm saying it returns an even. And it's just like returning, any other type of variable. You put the type of the variable in front of the function name, and then you have a return statement that returns an object of that type. In this case, result is an object of type even.
Okay, thank you.
Mm-hmm. So let's just play with this for a minute. So let's make A an even, which is 6. And let's make B an even, which is 12. Okay, so here I'm taking A, which is 6, I'm adding B, which is 12, that gives me 18. I'm storing the result in a new even called C. And I'm taking C's toInt method, which should return an integer, and I'm going to print that out after the string 6 plus 12 equals. And that should show me 6 plus 12 equals 18. So run main2. Yeah, I need a main method though. I went a little overboard deleting lines of code. Okay, so now I got a main method. All right, so there's 6 plus 12 equals 18. Life is good in the universe. So I could actually do this a number of different ways. For example, I could have said even c equals a dot add new even 12. And this would take a, which is an even number 6, and it would call the add method, and it would pass to it a new even number whose value is 12. And that would also set c equal to the even number 18, which toInt will return, and it'll say 6 plus 12 equals 18. I could also do this. I could set c equal to a new even number 6 dot add new even 12. And now I don't have an a or a b. I'm just constructing a number 6 out of thin air. I'm calling its add method and passing it the number 12. And that will also create an even number whose value is 18. And in fact, I could do this. And so what am I doing here? I'm constructing a new even number 6. I'm calling its add method and passing that a new even number 12, which should give me an even number 18. And then I'm calling the toInt method on that new even number. And this should return the string 18. All right, which it does. So this is not the easiest thing in the world to read, maybe. Although if you know what it says, it's not too bad. But this is pretty marvelous, right? This is, constructing entire objects and accessing methods inside those objects without actually using any explicit temporary variables. And that's totally legit in Java. Now, normally we would use temporaries and we would try to make this, pretty clear what we were doing, but this kind of thing works perfectly well. All right, let me mention something about class files. So when we were playing with rectangles yesterday, we had two classes. We had a main class and we had a rectangle class. And here, we've got our main2.java, which is going to create a main2.class, and we're using this even class. Okay, I haven't shown you the code for even.java. In fact, there is no even.java in here, but there is an even.class. So if you have a .java file and you compile it with Java-C, you end up with a .class file. Okay, that's kind of like a .o file with C programs. It's a compiled version, but we don't need to link it. Okay, simply having this class file in the same directory in which I'm running main2 lets the Java virtual machine access this file when I say I want to do something with an even object. So it's not exactly like a make file. It's a little bit like linking things together, but it's kind of done for us. So when I compile main2, I get a main2.class. When I say Java main2, what I'm saying is run a Java virtual machine, look inside this class for a public static void method named main that takes an array of strings as an argument. And if you find it, execute this code. And when this code is executing and it tries to do something with an even, it will look for an even.class in here. So if I were to try to execute my even class, it's going to say, I don't find a public static void main. And if I don't have an even.class, then when I try to run main2, I'll get a runtime error saying no class definition found. So it's looking for even, it didn't find it. Why? Because I don't have an even.class in here. I renamed it to even2. And when you get an error like this, you get a kind of nice little traceback, right? It's telling me it was at line 4 of main2.java, and that's where I got the exception, the error. But it's also showing me that this came from line 382 of URL class loader.java, which came from line 419 of this and 352 of that. And if I had the source code for all of these things, right, I would see where in that source code these calls were made that ultimately led to this error. So it's a little better than just segfault, right? It actually gives you some information that's pretty useful usually for figuring out what went wrong. And again, mostly we don't have to think about this. If we're doing everything in one directory and we're defining all the classes we need and they're all sitting in that directory, we just say Java C, we say Java, and everything works. But if we start getting into more complex situations where we're taking pieces of larger projects and trying to put them together, then we have to start thinking about how we manage all these classes, and that's a whole nother discussion. All right, so I spent a little while at the end of the morning class talking about something called a scanner. And a scanner is an easy way to do input from the user. So I would say go ahead and take a look at about the last 10 minutes of this morning's lecture, which is posted already, and see what I said about scanners. And there's code for that also up on the Linux server. Basically, you're only turning in the even class for PA1, which is just a class. It's not a main program, but you want to test it yourself. So you might, write something like this, and you might change these numbers around, or you might want to write a program that lets the user type in numbers and then turns them into evens and adds them and subtracts them and so on and so forth, right? And eventually we'll be writing code where we want to get input from the user. So a scanner is an easy way to get input from the user, to basically read from standard in. So check out the last 10 minutes of this morning's video. I worked through all of that, and we can talk about questions on that tomorrow. All right, any questions on any of this? All right, well, we'll call it a day for now, and tomorrow we're just going to run through some of the sort of general syntax of Java. It's a lot like C, but I want to just sort of touch on the different basic constructs, switch statements, things like that. So it'll be a little less of the sort of very heady new concepts. It'll be more of a review kind of thing. But take a look at PA1, bring questions to class tomorrow. Have a great rest of the day. I'll see you then.